6 pulse converters. Because of the requirement of special type of conversion transformer, 3 pulse converters are not popular. The conversion transformer is used to prevent demagnetization for large outputs and least ripple content. A 3-phase control rectifier with higher pulse number is used. Generally, for industrial application, 6 pulse and 12 pulse converters have been used. Two 6 pulse converters are connected in series to form 12 pulse converter. 6 pulse converters are used in industrial applications and 12 pulse converters are used in HVDC transmission. Advantages of 6 pulse converters are: requirement of series inductance is less, magnitude of ripple is less, probability of discontinuous current is less due to the reduction in lower order harmonics. Distortion on the input side is reduced. Commutation is simple. Now we'll see a 6 pulse midpoint converter. Now this is our circuit diagram, whereas this is our phasor diagram. Now this is also called double state control rectifier. Now this is an extension of 3-phase half-wave circuit where each thyristor conducts for 1/6 cycle. Each SER conducts for 60 degrees, and hence the iteration factor of SER and the secondary winding of the transformer are poor. These converters are also called M-6 converter. The output voltage contains 6 pulses for each cycle of the input voltage waveform. Now here we have assumed that the load is resistive R. If the R phase is positive, then T2 can turn on. If Y1 phase is positive, T1 can turn on, since T1 is in forward biased. And if Y is positive, T4 can turn on. R dash is positive, T5 can turn on. B is positive, T6 can turn on. As these thyristors are in forward biased when the supply is connected to it is positive. Now each thyristor can conduct maximum period of 60 degrees, and the minimum firing angle is 60 degrees, and the maximum is 180 degrees. If 0 less than or equal to alpha less than or equal to pi by 3, then this will give a continuous conduction. If pi by 3 less than or equal to alpha less than or equal to 2 pi by 3, then this is going to give us a discontinuous operation. The SARs are triggered in sequence of T1, T2, T3, T4, T5 and T6 at 60 degrees interval. When thyristor T1 is triggered, and it will conduct until the T2 is turned on. When the T2 is turned on, T1 is going to turn off by the natural commutation. Similarly, this is going to happen for every thyristor. Here we have the 6 pulses. The yellow line belongs to R, and the green line belongs to B, pink line belongs to Y. This is one cycle equals 2 pi, that is 360 degrees. R, this is R dash, Y, this is Y dash, B dash and B. If alpha equals to 0 degrees, then Y1 is going to conduct from the beginning, then the resultant will be R is going to conduct from here to here, B dash is going to conduct from here to here, and this cycle repeats. You can see here Y dash is connected to T1 and R is connected to T2, this T3, T4, T5 and T6. We got 6 pulse. Now if alpha equals to pi by 3 or 60 degrees, then from here to 60 degrees, 30 and 60. Here Y dash is going to start and continues to be in conduction until R is going to start, and R is going to start from here, since this is 60 degrees, or pi by 3. R is going to conduct. Similarly, BT is going to conduct, and here Y is going to conduct, and here R dash is going to conduct. If you draw that resulting, here Y is going to conduct, next here R is going to conduct, next B dash is going to conduct, next Y is going to conduct, next R dash is going to conduct. This belongs to T6, T6, T1, T2, T3, T4, and here we are going to get T5. We are getting 6 pulses. Now, if alpha is more than pi by 3, let it be 90 degrees or pi by 2 radians. The y is going to start pi by 2, that is 30, 30, and this is T1. Since it is an R load, it's not going to conduct in negative half cycle. So this will remain constant until the next thyristor is going to turn on. Next thyristor is T2, and T2 is going to turn on here. It's going to continue at 0, and next thyristor is going to turn on is B dash, that is this is T3. Then it's going to stay on 0. This is Y at T4, and this is R dash, that is connected to T5. Next, T6 is going to turn on. Yeah, T6 is going to turn on. So this is T6, T1, T2, T3, T4, T5. Here also we are getting 6 pulse, but this is discontinuous for R load when alpha is greater than pi by 3 or 60 degrees. We are going to get discontinuous operation. So for continuous operation, alpha should be maintained between 0 and 60 degrees or 0 and pi by 3 radians.